Okay, so this will be worksheet number 2 from the lecture number 2. As a summary from the lecture number 2, especially we talk about the beginning of the lecture number 2, reference frames, right? Because when you measure any quantity, so that quantity is measuring with respect to some reference frames. Simple example, if you are walking with 5 meters per second speed, that means you are saying that number by assuming Earth is at rest, right? But we know that Earth is not at rest. Earth is keep rotating, and you going to walk on top of the Earth's surface. Then actually, there are two motions happening, right? So because of that reference frame and also saying your numbers or any physical quantities with respect to some frames is very important. So all the numbers, all the physical quantities that we are measuring, we use it as Earth as rest, and we going to say the speed, acceleration, velocity, displacement, those things with respect to our Earth. So, but first part, we basically discussing why that part is important, and that also will give you in my first question. But after that, in physics, we discuss about the distance and displacement, right? So distance and displacement are two different things in physics, right? So best way that you can think is you're going to walk with your dog, and then if you need to walk from A to B, you probably select the direct path from A to B, right? But so dog try to go around, and then he will be back to the same place as you, right? So now this dog path, we call it as the distance. The path that you take as direct, this red line, is we call it as the displacement, because displacement is a quantity that have a direction and the magnitude, and distance is just the number that you can say as the distance, right? And second, we discuss about the speed and the velocity. And speed and velocity also different quantities in physics. If you if you go to your vehicle, that is basically say in the speedometer that measure the speed, because vehicle does not know how to measure the velocity. But with the directional and magnitude informations that we can express is by using velocity, by using vector information. That's basic definition, difference between the speed and the velocity. And then we discuss about the acceleration. As you guys know that SI units, we use this for meters, and this will be meters per second. And then we talk about the acceleration, right? So acceleration also have the unit meters per second squared, right? And after we discussed these things, we went to the average velocity, average acceleration, and also instantaneous velocity and instantaneous acceleration. The definition of those things are important. Average means, as a simple example, if you need to find the average of the velocity from V1 to V2, you know that you need to add them and divide by 2. That's basically called it as the average velocity, right? And also, if you need to calculate the acceleration, average acceleration, that will be the same way. And but the instantaneous means basically you are measuring the velocity or the acceleration at that particular time. So that means if you are walking like this, and then if you think about this is the time that you need to work, maybe 1 second, after 1 second at this point, the velocity, we call it as instantaneous velocity. At that point, acceleration, we call it as instantaneous acceleration. That's the difference between average and the instantaneous, right? So now after we discuss these things, actually we related this everything together by graphical representation. That's very important concepts, because after you know what is the displacement, what is the velocity, what's the acceleration, we know the definition of those things, right? So simple example is, if you start from one point and if you go to the another point, if this is your initial place, position, and this is your final position, X we use for the initial and final. Definitely X you using for horizontal direction, Y you using for vertical direction. Whenever we needed it, we can use it, right? So now displacement definition is final position minus initial position, right? After you define the displacement, velocity will be able to define, because velocity is basically displacement per unit time, right? Rate of change of displacement, we call it as the velocity. So that means you can write x final minus x initial divided by the time it will take. So now if we take time t, right? So now this quantity, this x final minus x initial, anywhere if you see the final and initial, that difference, we call it as change of that quantity, right? So that means this is, you can say, change of position divided by the time. That means displacement divided by the time is the velocity. And then when you go to the acceleration, when you go to the acceleration, you know that you can write acceleration as change of rate of velocity, right? So that means if you know the velocity in here, velocity in here, that your simple diagram, then v final minus v initial divided by time, we call it as acceleration. Again, this is change of velocity divided by the time is the acceleration, right? So now it's very important that you understand this in graphical way also. That's visualization that you can think, right? So now this displacement, you think about the car start from one point and go to the another point, and then if you know these two positions, you will be able to calculate the displacement, right? So after you know the displacement, what is the velocity means? Velocity means you take the time in between these two positions, and then you're going to divide that displacement divided by time, that will be the velocity. Now, what is the relation between displacement and velocity? That means if you have any plot, displacement as a function of time, we'll say you have displacement as a function of time. Whichever plot you see, will say I have a plot like this, example, right? So then you're going to see, okay, I know that this is displacement increasing linearly. That's the information about the displacement. So now how you think about the velocity? You're going to take the slope of this graph, that will be velocity. That means velocity is, in another way, slope of x versus time, or displacement versus time, we call it that slope. What is the slope means? Slope means you take the 2 point and then price going to divide by the time it will take, right? So now you can definitely see that this is the easy way to think it. If you think about this angle in this graph, that is called it as the slope, right? So that means slope in this case definitely a constant. That means velocity for this graph is constant. If I need to draw a velocity graph exactly on this time interval, that means velocity is a constant. It is a positive slope, positive velocity. If I want to calculate that, if I know the numbers, I can calculate it. That's the definition of the velocity. So now how do you go to the acceleration? So after you know what is the velocity as a function of time, then you're going to take, okay, I know I need to take the slope of this plot into the velocity. Velocity means slope of velocity, acceleration means velocity versus time, right? So according to the graph, it will be different, but here you see that slope of this graph is 0. Then if I plot the acceleration for this one, exactly same time interval, if I do acceleration as a function of time, it will be just 0 because there is no slope for this graph. Okay. And also you can go backward if you want. If we start from the acceleration, you're going to go to the your velocity by taking the area under the curve, right? And then you can go to the displacement by taking the area under the velocity graph. So that's how they're going to be connected each other, backward or forward. Forward we call it as derivative, backward we call it as the integration. Okay, but since we are not using derivative or integration, but we're going to get the conceptual way, that is basically taking the slope of the graphs. Okay. Okay, so last part of this chapter, actually lecture, we discuss about the kinematics equation, right? So one-dimensional kinematics. That's another important part right here, one-dimensional kinematics. So this is the last part of the lecture, and also we keep continue this one into the next and next also. So it's very important that kinematics we use for constant velocity problem, constant acceleration problem. So constant A problems, right? So that means the relation between velocity, displacement, acceleration, and time, everything together, we can derive three kinematics equations. Those are, we call it as kinematics equation, but useful when the acceleration is a constant. In that case, it can be 0 or it can be a constant, right? So that is, we call it as the kinematics. So now we talk about the three formulas. I'm going to write it for the x direction. You can also use it for the y direction by just changing x into y coordinate. So x final equal x initial plus velocity initial, x direction time plus half acceleration x direction and time square. And then we final in x direction, we initial in x direction plus acceleration x direction time, and the last one is we final x square plus equal v initial x square plus twice acceleration in that direction and the displacement, right? So these three formulas, you can use three of them together to solve the problem, or you can use, sometimes if the problem is simpler, you need to decide which formula you're going to use. But important thing is you really understand what these symbols means to you. So x is always velocity, f is always for x is always displacement, f is for the final, I is for the initial, a is for the acceleration, t is for the time, right? So those are the parameters. I want you to use exactly same formulas, same format as I use, not some random formulas from the internet. So now, as I mentioned, these formulas, you see that the acceleration is a constant, right? That's the only constraint that you have. You need to double check that you're using it correctly. And this x final, x initial, v final, v initial, those are instantaneous values, right, to that time. Okay, so because of that, those are not average values. Those are, we are saying at final position, this is the position, this is the velocity at that place, this is the velocity at that initial place, right? Those are instantaneous parameters. Okay, so I think we can move into the worksheet, because your worksheet also longer. Those are main parts that we covered in the lecture. Okay, so now let's move to the first question. So first question is about the reference frames or relative velocity, why it is important, right? So you have a train and you have a person, and we definitely have the ground. Because of that, we have three things here. Train is one, right? And person is another thing, and ground is another thing, right? So train, I'm going to use T symbol. Person, I'm going to use P symbol. Ground, I'm going to use G symbol. So now let's write what is given. This notation is very important. Train speed 80 kilometers per hour. That means we're going to use the velocity symbol for that. Velocity of the train with respect to the ground. First letter, velocity of that object, velocity of the train with respect to the ground is given 80 kilometers per hour. Right now, next, a person runs to the front in 5 kilometers per hour. Now it's saying the velocity of the person running inside the train 5 kilometers per hour. Now you need to understand this is actually with respect to the train is 5 kilometers per hour, right? So now we're going to move into the A and B according to the information given. A. What is the person speed with respect to the train? Asking person speed with respect to the train. Do we know that? Actually, it is given in the question. So you just need to write the answer. And B. What is the person speed with respect to the ground? Person speed with respect to the ground. Does it given? No. So now how do you find it? So always when you see P and G, you can insert the other frame you have on the question. So other frame, this is person and ground. The train is not there. So I can add the train into here by writing person speed with respect to train plus V speed of the train with respect to the ground. You see that this T and T is here, right? Then I get the P and G by inserting the other frame in between, right? So now we already know those things. We can write it. Person speed with respect to train is 5, and speed of train with respect to the ground is 80. Then your final answer is 85. Yeah. So that's how you solve the problem. So in by any case, if you have letter P, V, T, G, if you need G, T somehow, so then your answer you need to change into kilometers per hour. This is TG value. If you exchange your letters, you need to switch the sign. Okay, that is something extra. Okay, so now let's move into the second questions to get an understanding the displacement formation and how do you going to calculate it, velocity, speed, and distance and displacement for this trip. Okay, so now let's move into that question. Okay, so now it's a car travels 150 kilometers from Princeton to Philadelphia, then back 100 kilometers to Trenton. Find the displacement distance of the trip, because I want you to understand these two are different. That's why I'm asking you to calculate this, right? So part A is asking you to calculate the displacement. Displacement, we know that x final minus x initial. So now you know that you have Princeton, you go to the Philadelphia, right? And but you have Trenton in between, somewhere closer to the Princeton. This is Trenton, right? Not on the same line, but in somewhere there, right? So now initial and final, you know that this is where you're going to start because he's going to come back after go there and come back, right? Because of that, that's the final place. Now we can write x initial and x final. So you know that 150 and 100 back, that means this place, this is actually 50, this is actually 0. This is you start x initial, this is you final, x final is 50 and x initial is 0. I hope everybody understand that. 50 kilometers, right? And so now same question, it's asking you to calculate the distance, right? So now you see the distance is not x final minus x initial. Distance means you go from Princeton to Philadelphia, that is 100, and come back another 100 and you 150 and come back another 100. That means you have total distance. Your odometer will give you actually 250. So you have 150 forward direction and again coming back 100. Because of that, there are 250 kilometers. See the difference? Okay. That is part A. And now part B. Does the odometer in a car measure the distance or displacement? We discussed it many times. It is distance. And then C. Okay, let's move into the C. I just want you to see the average speed and the average velocity, right? So speed will be able to calculate, as we know, distance divided by time, right? So distance is 250 kilometers. And you're going to divide by the time, 90 minutes. Okay, so it's very important that you convert kilometers into minutes and write it in from SI units, or you can keep it as kilometers per minute. But since this is not that important for me to calculate it into the SI units, I'm going to just write kilometer per minute because I just need to see the difference. So this is the speed, right? And then velocity is equal to displacement over time. So now in this case, I have 50 over 90. Again, this is kilometers and this is minute, right? So now this will be equal to 5 over 9 kilometers per minute. Okay, so I did not convert, just leave it. And then you see that these two are not the same. They are different, right? Not the same. Okay, let's move into the next question about the graphical information. So now when you see a graphical representation, you definitely need to keep watching what it actually given to you. You see that especially you need to read the axis. This is velocity and this is time, right? As soon as you see velocity as a function of time, you need to understand that is you are working with the velocity and I should know how to do the displacement and acceleration, right? So now, before moving to the question A and B, what this graph represent for you is velocity as a function of time. Green represent velocity is linearly increase. Linearly increase. Let me write it. Fine. Read it. So linearly increase. So linearly increasing velocity, right? And pink velocity is constant, right? By watching the plot, you should be able to understand this. And third one is blue So blue velocity is decreasing, right? Linearly decreasing. So that information is important. So linearly decreasing, right? So now we're going to move into the question to see that what actually it is asking, right? So now part A is asking, explain about displacement as a function of time and sketch it. Okay. So now, first thing is displacement. So can you think about the displacement by watching the velocity graph? You will be able to see it, right? Because if you have a displacement graph, if you take the slope of that displacement graph, that should provide me the given plot. So I need to match it up, right? So before moving into the part A, actually I will move into the part B first, because part B is easier to see from the plot, okay? So part B, explain about the acceleration as a function of time. So now, again, we can write it by using the color green, right? Green part. Green part, you see that velocities keep increasing linearly. But what will happen to the acceleration? That means you need to think about the slope of this graph. You see that this slope, that the tangent of theta is the same for all of them. So that means green part, your acceleration is a constant, and also it is a positive slope, right? Slope is a constant, that means acceleration constant. I would say positive constant, right? So now if I plot exactly same graph with respect to my time, I'm going to expand this drawing here. We can draw the same graph in the same axis, right? This will be my time axis. This will be my acceleration axis. Now, I did not calculate it. If you want, you can calculate it. But from the graph, in the green part, this part, I'm going to slow it down, and 4 seconds and 8 seconds, right? 4 seconds and 8 seconds. So this is 4 seconds, this is 8 seconds. So in the green part, I should have a constant acceleration. If I want to find the acceleration, I can take the slope. Slope will be basically this height divided by this height, and take the tangent of that. This is 10 divided by 4, and take the tangent. You will be able to find it. I'm not worrying about how much it is right now. So you can draw it, and I calculate that as actually 2.5 around. You can ask me if you don't know how I calculate that. So meters per squared second, right? That's the green part. Now we're going to move into the pink part. Pink. So in the pink part, you will see velocity is a constant. When you take the slope of the constant graph, there is no slope. That means your acceleration at that part is 0. So 0 acceleration. Okay, last part is blue. Now, last part from 8 seconds to, I think it is around 10 seconds. So blue part. So now you see that the slope, again for the slope of this one is a constant, right? But it is, slope is negative direction. But compared to the slope on the green and the blue, blue is more steeper than the green. That means the slope is actually higher than that. If I want to calculate it, it will be 10 divided by 1 in here, and take the tangent of that, then you will be able to calculate the slope. But by watching the graph, I will be able to see that slope is greater, but it is in negative direction. I will extend this one. I'm going to draw my blue graph here. You can see by using the calculation, you're going to get it around 5, I think. Okay. So that is my negative direction of the acceleration. So now blue has again constant acceleration, but negative. Okay. So now we conclude with the acceleration. That's the easy thing to go. So now I need to go back to the displacement. Now, how do I draw the displacement as a function of time? So let's draw this line first. My time axis and my displacement. I'm going to say x and time. So now, by watching the blue, green part, right? First one is the green. So in green part, I know that if I draw something on this plot, that should give you the increase in slope. Green is giving me increase in displacement that will give me a linear increase of the velocity. So this will give me the increasing, but not linear. What that means, increasing, not linear, okay? Not linear. Okay, so now what that means is, think about to get the slope increasing. That means my graph should looks like, actually, not take, drawing is bad. So increase in slope. What that means? Increase in slope means take the slope here. You see that this slope is little greater, this slope is little greater, and this slope is little greater. So keep increasing the slope. That is the top graph. That's the velocity graph. Okay, that means my displacement graph should be looks like this. Okay, so now we're going to move into the pink part. Now in the pink part, slope, if you take the slope of your displacement, that should be a constant value. To have the slope constant, you know that you should have a linear graph in this part, right? If I take the slope of this, you see that slope is a constant, then you can get the top graph. So linear increase. Okay, so now my last one is blue, right? So now last one, what you should see in your displacement. So your velocity is negative slope. So that means I definitely know that my displacement graph should be giving me the decrease in slope. Decrease in slope means this is increase in slope that we discussed first part. And decrease in slope means you basically need to do this kind of plot. See that it is decrease in slope, right? So now this is decrease in slope. Not linearly again, right? Not linear. Okay, so that's how you combine or understand this everything together into your knowledge. Okay, so now let's move into the last question. So last question, I put it into the kinematics problem. It's very important that kinematics problem, you need to work on a couple of examples, do the homework, find some question in the textbook, and try to do a couple of more questions on at your end. Then you will be much familiar with that. Okay, so now don't draw a ball. It's very important. First step is you draw the diagram, right? You need to follow these rules during your homeworks or your quizzes, because I am definitely looking for your understanding, not the final answer, right? So now first thing is you need to draw the diagram, right? There is John, throw the ball straight upward. It did not say John is on the ground. John may be in some building, I don't know, right? So we're going to Just draw it as we understand. After 2 seconds, the ball reached its maximum height, then it free fall down with the 4 seconds land to the ground. So now by watching the times, even you can say 2 seconds go up and then 4 seconds go down. So maybe John is sitting on the ground, maybe ground is little below than the and where the John sitting. We don't know. We're going to find it that question at the end. So right now we'll say there is John, right? John is here. He's going to throw the ball. There is a ball and ball going to throw up. Then it will go up and then it will go down wherever I don't know the ground or maybe the below that, don't know it, right? So somewhere here, maybe here or here, doesn't matter. So now, after you realize the problem looks like this, next step is labeling the things, right? So now you can go and label the things, or you can move into the question and see what is asking, right? So according to that, you can label it. But in my opinion, you need to go to the question and think what you need to calculate. And then according to that, select which portion of the problem that will make sense for you to calculate that part. The next part, maybe you need to consider whole problem, or maybe you need to consider part of that. You're going to decide that at your end, right? Different people can do the same problem different ways, but everybody should get the same answer at the end. That's why physics is most of the time is really, really interesting. Everybody going to start in different ways and do the problem in different methods, but finally get into the same conclusion, right? Okay, so now my first question is calculate the initial thrown velocity. I need to find the initial thrown velocity, right? That means definitely I should have a label in somewhere here that is the initial velocity that I need. I'm going to label it actually as y direction. Although we are using one-dimensional problem in this lecture, it is very important that you understand the x and y coordinate system, right? So now, as soon as you decide that position is important to you, you decide where is your origin of the coordinate system. Usually, in my experience, I would say you use your initial position of the problem that you're going to solve as your origin. So that's the easiest way to do it. I'm going to select this as the origin. That means wherever this direction I measured, that will be a positive quantities. If I measure anything in x direction in this problem, we are not doing anything for the x direction. We are doing everything for vertical motion. If I measure anything upward from this point, that will be positive. If I make anything downward direction, that point, that will be a negative. So that's the idea about the coordinate system. Now I have the coordinate system label. This is where my 0, 0 or the origin. So now next step is I want to calculate the initial thrown velocity. Now I know these three fundamental kinematics formulas that will work in y direction. I can write it as one equation y final equal y initial plus v initial y direction time plus half acceleration y direction and time squared, and then v final in y direction equal v initial in y direction plus acceleration y direction and time. And third formula, v final y squared plus v initial y squared plus twice acceleration in y direction and displacement y final minus y initial. Those are the three formulas that we learn to use it for the y direction, right? So now, according to these three formulas, I need to decide, calculate the initial thrown velocity. I need to decide which formula I'm going to use for the first part. Do I need to use whole motion of the object, or do I need to use half of the motion of the object according to the given information? So now according to the given information, what we know that when the ball reaches the top, the velocity at that point is 0 in y direction. So that means I can definitely select the first part if I want, right? Or you can think selecting whole part, but when the ball goes down, do I know the velocity at here? I may be able to find it, but I have no known that velocity at all, right? Because of that, considering whole motion for the, at least for the part A, make your problem complex for you. Because of that, easy way to do it, you choose the easiest uh, method that you can use. Then just after that, I'm going to make a space in here. Just after that, you're going to write. Let's see that I can insert the page in here. Good. Okay, after you decide that, make sure that you write. So we're going to do the part A, right? Explain your problem. That's how I know that you understand it. I am going to use the ball path from John hand to the highest position. That's what we're going to do for the first part. That is what I'm going to do. Somebody else can do something else, right? So now, after you decide that point is the one that you're going to use, okay, so now I have my final position defined for me. So I'm going to use this as my final position in y direction. Velocity is 0, right? So do I know the height that the ball reach? It's not given. Maybe I need to calculate it. I don't know y final yet, right? And do I know the time for that? Yes, time is given. I'm going to write all known things in here. I'm going to erase it later because it's right in on top of the letters. Time for the going up is 2 seconds, right? In addition to that, there is no other informations given for that part, right? So now I need to decide, okay, now I need to think which formula should I use to find the find what? VIY. I need to find VIY. So now you can see VIY is in these 3 formulas, right? But do I know any information in this formula about the Y final place? Y final place not known, and time is given, right? So, because of that, this has 2 unknowns. This formula is little complex to use in this problem. And last formula, Y final, don't know, and also V initial, don't know, that also complex. You can solve it by using 2 different formulas if you need, but if you can solve the problem in single slot, that will be the easiest way to solve the problem. That's why you need little practice and you need time on organizing your problem into your mind and understand it and then process. Okay. So now according to the information, I definitely know that second formula is the best formula for me to solve this, at least first part. After you decide that, write the formula. You're going to use second formula. Yes, V final y direction equal V initial y direction plus acceleration y direction and time. So again, use your notation. You use in upward as positive, right? So now as soon as you label that and as soon as you have information in your diagram, V final y, we know it is 0. If something is 0 in next step, make sure you make it 0. That will simplify your question. But don't plug the values to any other variables yet. So because we like to see it algebraic way. So we have v, I, y. That notation, I'll just keep it. I need to find it. And acceleration, y, and time, what I need to find is v, I, y equal negative a, y, and time. So this is where I'm going to plug the values, right? So now do I know the a, y? So yes, we know the AY value. AY is 9.80 meters per square second, but it is always attracting towards the earth. Because of that, it is, according to my symbols, see my y direction is here positive. Because of that, that value is negative. So now we are ready to plug the values. Okay. So I have negative. I also have negative in 9.80. And I also have the time given, that is 2.00 seconds, right? So now your answer will be in units of meters per second and 9.8 times 2. So that will give you the answer 19.6 in sig pics, because I have 3 and 3, so I will keep 3 sig pics. So do you agree with that answer? Should it be positive or negative? Think about that. You see that in here? I throw the ball upward. So now, yes, so it should be a positive number according to my drawing, right? I select the upward positive, I get the positive answer for the VIY because I am throwing the ball upward. Everything should make sense after you solve the problem in your end. Okay, so we're done with the A part. Now we're going to move into the part B. So I'm going to probably scroll up and down a little bit. I cannot make it 100% first. And let's move into the part B in here. Okay. You can redraw it after read it, or you can just go up and see what is the problem is, right? So now second part, calculate maximum height measured from the John head. Now according to your figure, it is asking y final for you to calculate. So now you know the v initial, v final. So you know the time. So now you know the y initial also, because this is, we start at y initial equal 0. So now you're going to decide which formula will work for you, right? You can use first formula because you know all the information you need, right? Or else you can use the third formula. Second formula not useful, there is no displacement. But you can use third formula even without the time, since you know the v final and v initial. So that means first one or the third one will work. Whichever you like, you can use it. I'm going to use the third one. Okay, so after I decide I'm going to use third, I'm going to write it. V final y squared equal v initial y squared plus twice acceleration y direction y final minus y initial. I'm going to use it in this direction. So now v final y definitely 0. Because of that, make it 0. Now next part is viy. I already have the value, but I'm not going to plug it yet. Then plus twice acceleration y also, I know it. I will just keep as a algebraic way, and y final I want to find it, and y initial was 0, right? So now you're going to solve it for the y final first and then plug the value. Now you see y final in this formula, subtract the v initial y in both sides first, right? And then you're going to divide that by twice of acceleration y. So now we're going to plug the values. So now make sure that you know that y final should be a positive value. It is a height. Because of that should be a positive value. We'll say physics give us that. So VIY is 19.6. We calculated in the first part and squared it. And then you're going to divide that by twice of AY acceleration, that is negative 9.80, and negative will cancel out. Now you can find the answer by putting into the calculator. Yeah, so it is 19.6. In meters, you see, you get the positive number as you expected. Okay, that is part B. So now we're going to move into the part C. Calculate velocity of the ball before it crashes the ground. Okay, so before it crashes the ground. So we need to calculate the final velocity when it crashes the ground. So now you need to think, since I am working with this crashing part, so definitely I need to think the part that I need for the problem. So that means, don't know where is the ground is yet, but going to decide final position, right? What I need to find is V final in this place, right? And that's at least that's the part C. So going forward, we may need to find the distance also, but V final, right? So now you're going to decide, do you need whole problem starting that you label initial to ending that you label at crash the ground, or maybe you can use the half of the motion, that means probably maximum height point to the crashing ground. So that you're going to decide as you want, right? So now I would like to use the whole motion. So maybe you would like to use the top to bottom. So that's totally up to you. But whatever you decide, you're going to write that on here. So say C. So you can choose whole motion or you can choose half of the motion. I'm going to consider whole motion. Okay. So considering from start to end, right? So that means if you want, you can redraw it. Going to land here. This is where you're going to choose initial. This is where we're going to choose final, right? So now acceleration always in y direction, 9.80 meters per square second. And now you have the initial velocity if you want in here. We already find it, y direction. And V final is the one we need to find. So now I'm just redrawing the same diagram that we had in there. So I'm going to choose this as my origin again, X and Y direction, right? So now, now we know those informations according to the given information. This number we found it 19.6 meters per second. Okay. Other than that, I need the time for whole problem, not only the single part. You remember that if I scroll up into the question, your whole time is 4 seconds to the crash the ground, 2 seconds will go up. That means whole time is 6. Okay, 6 seconds. Okay, so now what I need to find, V final. Now, which formula you're going to use? I need to find V final. I know the V initial. I know the acceleration. Then best formula from the list will be V final Y equal V initial Y plus acceleration Y and time. Going to use this direction, right? So now by watching this, final is going downward direction. That means I should end up with the negative number. Keep that in mind, okay? So, but it will automatically come up from your formula. V final Y, we need to find it out. V initial Y, I'm going to plug the values because everything is set up now. VI Y is the initial number in positive direction, 19.6. And acceleration is negative direction. Because of that, I have negative there, 0. And time is 6 seconds. So now V final Y will be plug into the calculator. You're going to get negative number, which is 39.2 meters per second, as we expected, because ball going downward direction at the end. Okay, so now last part, D. Go and read it. D. Calculate the distance from ground to John hand. Do you think John is on the ground or not? So now I need to find the distance from where to where John hand to the ground. I can use the drawing that I have it on the part C. That means I basically need to find this distance, right? So now if I use exactly same considering that I have done in part C, I can use same consideration for the part D, because the displacement is the one that I need, because I need this red distance. That means if I know this place and if I know this place, then I will be able to find the displacement, right? So now we're going to use in your formula set. In your formula set, you see that I have a time, I have to find y final. Best formula, second formula not going to work because there is no displacement. You can use third formula or you can use first formula. So whichever good for you, you can use it, right? So since we did not use the first formula at all yet, I'm going to use first formula for this problem, but you can use third one if you want. Okay, so again, I'm going to considering same part of the motion as C. Okay, so now going to use V final equal Y final equal Y initial plus V initial Y time plus half acceleration Y and time square. So this formula is very useful most of the time, but sometimes because it is a quadratic formula, you need to make sure that you do not have two unknowns in the formula, then you need to solve the quadratic formula. But sometimes we may need to do it because there is no other way that we can solve the problem. Then you can use and solve the quadratic formula to find the time, right? But other than that, try with the other two, and if it not work, then you move into this one. Okay. Okay, so now we have the to find the y final, definitely y final equal and y initial, this is where you start, so that will be your 0 position, right? And then v initial y, since it is the solvable formula that I have everything on the left side unknown and right side known, I'm going to plug it, okay? Plus VIY is a positive number, 19.6, and total time 6 seconds. Okay, and then I have plus half. Now I know acceleration negative 9.80 and time is 6 seconds and power. Okay, so now you're going to plug into the calculator and solve for the y final. What you are expecting according to the problem, y final should be depend on you go to the ground or you go into the below that, but definitely the value that you are getting in here is a negative number because according to my place 0 here going downward direction. Solve it and I get 58.8 meters. Okay, so now it makes sense. Now you go back and see, you answer the question. Do you think John is on the ground? What do you think? If John is on the ground, that means John should be taller around 58.8 meters. No one is taller that much, right? The normal human height is not that big, right? That means John is not on the ground. So, right? Sitting on the ground. Okay, that's it for this.